you can arrive directly to GDAL.org, okay? GDAL.org. So this is really a backbone. GDAL is already more than 20 years, probably was the beginning of 96 or something like this. 90, yeah, something around. In the 2000, I was fully using, and it was made only with 3 commands. And now we will see that there are plenty of commands. GDAL is behind all the open source and private geographical software, and is responsible for all the setting and manipulation of the raster and vector file. In particular, GDAL is working. The command that starts with GDAL is working for raster manipulation. Rather, the one that you're using for vector is going to be OGR. OGR. So let's start before with GDAL, and then we will see some example of OGR. So first of all, programs. So if you click in programs, as I mentioned, when we were using, these are all for raster manipulation. Rather, below over here, there are OGR vector manipulation. When I start to use it, more than 20 years ago, there were just 3: GDAL info, GDAL translate, and GDAL warp. That's it, okay? But thanks to the open source community, that's been growing quite a lot, now is really the standard behind. So under the scene in all the software, including QGIS, they are using the binding, the so-called binding that are written directly in C. Actually, now I think there are all of them in C++, to operate on raster file and vector file. They can read all the different formats, all of them, okay? The other day I was just merging, for example, GPX for my hiking activity. I have several ones. I want to make all together. I never did it because it was not coming to the needs. And I just Google it, and OGR was able to merge all the GPX. So in this case, also in the Discord, Gabriel Ortega was asking about how to open S3 geodatabase, and we can see, and I already mentioned that with OGR info we can working and read S3 geodatabase. Then maybe we can go deeply in his question as an example. Let's see the raster program. This one, consider GDAL as a pre-processing tools to do raster manipulation, for this case, raster manipulation. So everything when you think about pre-processing of a raster image, you can do with GDAL. So in other words, cropping, warping, changing pixel resolution, selection of band, excluding of band, what else? Go from rasterize, so going from raster to vector, or from vector to raster, and then some others that are more specific. What you cannot do it is something that really a raster procession, for example, making classify an image. So when it's already something more than pre-processing, then you cannot do it. Then you can move to the other software that is PK Tools, that is really the brother of GDAL. And actually, for the people who are coming in Austria, they are going to be the developer. Last year was in Matera, and they're going to come Peter, the developer of PK Tools. And I'm going to point also a lecture that he was made by him last year for the use of PyGeo, that is a Python package for the raster manipulation in Python. Very powerful. But let's focus on the understanding very well the GDAL. Okay, so let's see some over here, some of the most important one, and then we move to the example. So the first one that I mentioned, GDAL location info. So this one, sorry, GDAL info. This one, as you can see, the syntax is the typical syntax with bash. bash syntax. Now you should be able to see immediately. So you have always GDAL info, always the command, then whatever is between square brackets is optional. And then you have, for example, something that is must be there, the destination data set. So all these one are the optional options that you can read carefully over here what they can do it, okay? So for example, even if you're scrolling down after all the different option, you can see that there are some example. Now they're getting more and more examples. At the beginning, they were not, so it was quite hard. For example, if you run the GDAL info of any file, you can get immediately the metadata of the file, okay? So in this case, it's going to tell you the size of the matrix. The TIFF is nothing else than a matrix, so 500 by 500, this is quite small. Then it's going to tell you everything about the coordinates, the projection. And then over here is going to tell you the extent, okay? It's going to tell you the extent. So, and this is quite good because every time that you receive a raster file, even before to open, you are going to run GDAL info to understand what is going on, okay? So in this case, you can see, okay, it's a small file, is in UTM, because you immediately see that are not degree, okay, because it's a very huge number, so it's in meter. And actually also over here is written that UTM zone 11, okay? So can I open? Yes, it's going to be, if you check the file size also, it's going to be a few kilobyte, and you can open in QGIS or in OpenEV without problem. Okay, so this is going to be really important for a first understanding of what is going. So then another one very important is the GDAL translate. GDAL translate, translate. Okay, so GDAL translate, also this one has been increasing quite a lot, all these options, and you can do several raster manipulations. So you can do, mainly you can do change pixel resolution and cropping, okay? These are the main one. And of course, when you cropping or you change the pixel resolution, you can also change the format. So you can go from TIFF to HDF, from HDF to TIFF, from NC net NC net CDF to TIFF. So from any raster to raster format, you can change, okay? Is also very good to change the data type. And I'm going to spend a bit of time about this data type because it's very important during the lecture. Over here, you can see that, you can set up try always to remember project win. Okay, so in this case, project win is going to be project win, stay for projection window. So in this case over here, you are going to insert the lat long of your cropping that you want to do. Rather, this one, for example, source window, you can insert, the pixel position. I want a cropping from pixel number 10 until 20, and then down the same for the Y and X. Always read this one, because sometimes quite often, and we will see, they are going to be inverted. So over here is, for example, is upper left X and then upper left Y. And sometimes is other way around, they're getting this one and not this one, okay, as a first one. So always try to identify this. You can do also some scaling. So during the translation, so if you have, from 1 to 10, you can stretch the number from 1 to 100, okay? So you can do a lot of manipulation with GDAL, and we will use it a lot, especially for data manipulation before to enter in Python. You can do the same stuff in Python, but I would say do it in Bash with GDAL. It's going to be faster. Everything is going to be aligned. And then when your file are ready, you enter in Python and you do just, you can do some more processing, some classification, and you can do also some some classification of image with machine learning. Gabriel.
Do you have any, is it working?
Yeah.
Do you have any option there to pass a shapefile or
perfect
ready-made format to cut?
For cutting. Okay, so there are two ways. Over here, there is somewhere, I don't know if it's here or in the other one, there is one that is called cut line. No, over here is not cut line. Can you read some cut line? Control F, cut. No. Okay, so, but in GDAL warp, I think they inserted. Okay, so in other words, Gabriel was asking, can I use a shapefile to crop it? But GDAL translate, GDAL, where is warp? Here. But GDAL warp should be cut line here, okay? With the cut line, you can use it an external data source, and you can go and read down the information. And actually, you can even use a layer. So be careful when you do cropping with a shapefile. The shapefile is not a raster file, so it's going to do something with the pixel. It can be included the last pixel or can be cropped down. You can, I think you can place this one with some more option, but I prefer always to getting the coordinate from the shapefile and then use it, this one, for cropping, okay? Because in this way I can understand better how I'm going to use my shapefile for cropping. So you can do it, but if you want more flexibility, I will show you how to do it, okay? Very good question. Anyone else? Let's see. Can I do, I like this question. Can I do, tell me something else.
I had a question about that, about the cropping. I haven't tried it with cut line. Is this just cropping to a bounding box, or can you crop to any polygon that's in shapefile in the layer that and the condition that you specify with the CWAY?
No, and this, so this one is going to be a bounding box, okay? It's going to be a square or just a rectangular, okay? Cannot be a triangular or something strange as a shapefile, okay? So even if your shapefile is a triangular polygon, is going to cut using the extent, and we will see which one is the extent of the shapefile, as the minimum maximum of xy and minimum maximum of x and of y, okay? So in that case, is not only the cropping that you want, but you want also the masking, because you want only to select the area under the polygon of the shapefile. So you need to cut and also mask out the part outside to the shapefile. In that case, you need two actions with GDAL and with PK tools, one for doing the cropping and the other one for doing the masking, okay? In that case, it's going to mask everything outside to the shapefile, and even if there are two polygons, it's going to be just whatever you have into a two polygon. So all this kind of operation, you can do it, very good. Sometimes can be only one command, and sometimes you need 2 or 3 commands to arrive to what you want, okay? So it's a matter of really searching and understanding different commands that you want to combine. Okay, another question.
Okay, I'm going to ask, what's the best way to reproject in a different coordinate system? Because I used the RioX-Array, but it's not always working properly.
So you use what?
I don't know if I pronounce it correctly, RioX-Array. It's the package of the
X-array, okay, yeah.
stereo and
yeah, so with the GDAL warp, we can do any kind of projection. Something very important to identify is over here, you can have the source projection and the target projection. T stay for target and S for source. And over here, you need to specify the APS-G code, okay? And we will see some example. Actually, let's see down and to see if there are some example. All the GDAL command, and especially the one that do not have the .py, are written in C++. Okay, so this one rather the .py are written in Python. So Chiara, you cannot get something faster than this one, okay? So even because Rasterio is an interpreted language, so it's going to be much slower than GDAL warp in this case. So I always say spend a bit of time to prepare your data under GDAL, and then when they are ready to go, then you import in Python for any kind of analysis, more deep analysis, okay? But this is very useful for this kind of application. Let's see if there is an example. If not, we come back during the exercise. Okay, so these are the different example with the GDAL warp and the use of no data and destination data. We'll spend also time about this one, but let me see if there are, yeah, it's important also the memory use. You can allocate some specific memory for your computer, and you can also do multi-core processing for GDAL warp, okay? So that really in the last year has been really use it quite a lot. Yeah, okay, perfect. So over here is how you identify the projection of the target resolution, and we will see this one from where to get this code, the so-called APS-G code, okay? And you can use it a code, but you can use also a proj string, they call it this one, okay? So you can use the two different way. And also this one, we are going to see how to use it, okay? So due to that, everybody is doing all these questions. Let's jump to the exercise. In particular, if you're scrolling down over here, you are going to get to this one, and we are going to follow this little example to carry on our analysis, okay? Today, I don't know why, but it's very slow, the opening of this page. Okay, it's open. Okay, so we can go directly in our, so now you should be able to know how to do it. So you enter inside to the folder, copy, paste, and then you open with the Jupyter Lab. Actually, this one has been changed already. Okay, I open with the Jupyter, sorry, like this. Okay, I will use Jupyter Notebook because I think something has been broken yesterday when I was trying to do something. GDAL OS Geo, Jupyter Notebook. But you should be able to use Jupyter Lab. Okay, perfect. So now let's working also with the terminal if I have some other analysis to do it. Okay, we are going to work directly in this folder, okay, where I have several files. So in this folder, you can run, and you can see that there are several TIFF files, and in particular, we can open one in particular with the GDAL info. Okay, so over here, I'm going to run the GDAL info, and I'm going to get all the information, as I mentioned, about the projection. Okay, so over here, you can identify that the information of the projection, and something. Yeah, 1 second. I want to see if they. Yeah, okay. Something extremely important is the so-called APS-G code. So if you just Google it, APS-G code, You put a number, even a PSG code. Yeah. Constant. Come on. Anyway, if you go check, okay, this one spatial reference, yeah, this one spatialreference.org. Okay, this one is going to be your reference for the PSG code. And in particular, if I put, for example, the lat long, when we talk about lat long, and you put the 4326 is going to be the lat long, and you can immediately see that you have all the information of the PSG 4326. Okay, so this is when everybody talk about lat long, this is the code that identify the lat long. So something very important is also this table, okay? So this table is giving to you information about other kind, because sometimes in some software you can specify this word, like we say, like we saw in GDAL warp, but some other times you need to specify some other string that identify the PSG code. So in particular, we have the PRJ, that this one you should know because is the one that is present in the shapefile. So this PRG is nothing else than a text file that identify, okay, identify the same, the APSG 4326, okay? And this information is the one that you, when you print it in GDAL info, you are see in the text, and we are going to check it. And also something very important is the proj4. This proj4 is also a very important string that probably some of you have been already using inside R or inside Python to identify a specific projection. So once again, when you don't know which kind of projection, or you are missing information about the projection and you are trying to guess it, which information are over here, try to come in this side and do a bit of reverse engineering to understand what is going on. So for example, if you write also here country in the searching, if you write Italy, is going to come all the different projection that we are using, and in particular, Italian people should know the so-called Monte Mario projection 1 and 2. So if you click over here and use this code, are you sure that are going to be projection information? Okay, so sometimes if the file come with the projection information, like the one that I was just showed before, like this one, good, no problem, okay? But sometimes they come completely with an unknown projection, okay? It can be even the lat long. So over there, or you have to ask to the author, or you have to try to guess it. Most of the time you guess it because you don't know the author well. And then for catching how to do it, you can do an overlay with the file that has been assigned the projection with the OpenStreetMap in QGIS. If everything is matching, then the projection is correct. This is how I usually do it, okay? But quite often is a matter of experience, matching, understand, especially if they are local file, you know, they are not in an important repository, some friend give to you, then that one that can be a bit messy with the projection. Something also to really understand immediately is the, over here, if we are talking about lat long, so degree, or we are talking about UTM. I don't have UTM, oh no, maybe Mercator, yes, this one. So over here, you can see immediately that are degree, and usually the degree, they are very small. They go from minus 180 to plus 180, minus 90, plus 90. So you can immediately see that are degree, okay? Rather, if you talk about UTM, so meter, a part that you can have over here, the information, UTM stay for Universal Transfer Mercator, and they are in meter, okay? So in the meter usually are a very huge number. Okay, so when you see this huge number, more than 1,000, then our meter, and also the pixel size is in meter. Okay, so this is where you have to be careful always, because they say pixel size, but they don't tell you the unit. Okay, so you need to do a bit of geographical knowledge to understand if they are degree or millimeter. So again, when they are big as an extent, then they are meter, this number. Rather, when they are small, between 180 plus 80, like this one, and they are negative, these one are quite never negative. Rather, this one, they can be negative, then they are degree. And of course, the pixel size are in degree. Okay, now let's see how we go from degree to meter to also to understand what we are talking about. Okay, so if I get the calculator, so anyone had a problem with the projection, that has spent days and days to understand the projection system and so on and changing. I think everybody, yeah. Yeah, sometimes, especially with the data are messy, you can spend a lot of time. Anyway, anyone knows or try to guess it, how much in meter is this number and where is coming from? That I think everybody saw this number in, or a brother of that one, let's say, but where is coming from and how much it is in that one. Okay, let's see if somebody knows. Saverio, maybe you. Do you know where this number come from? But you saw it. Okay, so this number come from 100, yes, 1 degree divide 120. No, why not right? 1 divide 100. Because it's measurement degree. No. Okay, forget. Okay, Python. Okay, that one comes from 1 divided by 120. Okay, so I get the 0.008. Okay, so this one is corresponding to 1 kilometer at the equator. Okay, so try always to remember this number, and then from here you derive all the others. Okay, and this is also when they say 30 second. Okay, 30 arc second, this one is the 1 kilometer correspondent, okay? Because indeed is, is 120, because if you do divide by 60, you get 1 degree, yeah. So if you get 60 divide by 2, you get the 30 arc second, okay? So rather, if you do it, this one, if you are adding 1 0 in the middle, okay, so you're adding 1 0 over here, is the so-called 90 meter. When they say pixel resolution of 90 meter at the equator is this one, rather 1 kilometer is this. So if you remember this 1 kilometer, then you can derive all the other. When they say, when they say 500 meter, for example, the MODIS, you can immediately see that is the typical 0.04166666. Okay? So is it clear? So anyone was doubting or
I think
try to understand where they come from?
Point there is at the equator, right?
Yeah, perfect. Always to specify the equator, because it's getting smaller, so up, down. Yeah, in the northern part, Europe is still okay, more or less, but as soon as you go north of Europe, then it's going to be but this one is give you an understanding of how much is the value that you are working, okay? And we will see how to be really picky with this number if we want that our file are all of them are aligned in terms of extent and pixel resolution. And you can think that if you're working with big geodata, this little rounding can create issues, especially when your matrix is very big. Okay, so that's why it's very important to understanding this kind of concept. And quite often, these, especially people that, Python, I don't know, but especially people that are working with R, they give you something always like this, okay? Or even like this, you know, that are not rounded in a proper way, okay? And of course, this is close to this one, but then if you have a huge matrix, and you have one raster like this and one raster like this, then this difference in a huge matrix can create a pixel shift in the last pixel, okay? So always try to be picky in the term of the extent.
I have a question.
Yeah, please, Kip.
So can you just explain? So 0.0083 is the pixel resolution, which means how many pixels will represent 1 kilometer at the equator?
Yeah, no, this 1 pixel at the equator, okay? 1 pixel at the equator is going to be 1 kilometer if you encounter this pixel size. You know, pixel size is 1, okay? Okay, so this one is for 1 pixel, so its degree at the equator is correspond to 1 kilometer. Okay. Of course, if you have this one, that is the so-called 90 meter, you need the 10 to arrive to 1 kilometer. And then you say you should have 11. But this is the way how it's expressed in remote sensing and raster jerk, you know, terminology. But so don't take it as a math that value 1 kilometer 90 meter, because it's not, but it's the usual speaking when you write, you know. So this is where it's coming from. So pay attention about this. Anyone was struggling about this? Yeah, Chiara.
So I have a question, because I noticed that in the file that we have in the notebook, when it is in UTM, there are different projections. I always wonder why that is in the metadata.
Yeah, sometimes is true, is confusing this concept. And the best way to do it, there is this command. 1 second, I think I have it here. No, yeah. There is, okay, let me exit from Control D. There is GDAL, that I never remember, GDAL inf. Yeah, so this one, okay? So this one is giving to you information about the project information. And actually, you know, you can specify which type of project information is that file, okay? And you can get as a proj4 or as a, different one. So if I do find any TIFF, I get one TIFF, and I do GDAL info, and I get this one. You know, you can get the proj4 that identify this projection, okay? I'm not sure if you can go back to the EPSG code. This one, probably not, because over here I didn't see. Ah, no, here, yeah, perfect. So if you do this one, if you do -O and you put APSG, is going to tell you the APSG code of this projection. So you can go from APSG, go to the file, and then from the file you can also retrieve the projection. Okay, Chiara? Good. Anita.
Yes, I have a question. If I understand, if I want a resolution of at 13 meters, I have to do one divide 120, divide 10, divide 30?
Perfect, yeah. So in other words, yeah, Python. Yeah, so keep in mind always 1 divided by 120 is the 1 kilometer. So you want a 30 meters, so it's going to be divided by 10, divided by 3.
Okay.
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 So this one is going to be the 30 meter.
Okay.
Okay.
Yes.
Always remember this one. Okay, 0.00833333, and then that you remember that is 1 kilometer, and then from there you do the math by dividing or multiplying, and you can derive also the other. Okay, so the same, if they tell you half degree should be, you know, 1 divide by 6, yeah, half degree. So it's like to multiply this by, yeah, by 60. So this one is going to be, how you do it, probably like this. Anyway, 60 by, how you do the multiplication in Python? Because I do the and then, sorry. Okay, so this one is going to be the 0.5 degree. Okay. So always remember one, and then you derive all the others. Okay, this is very important when you do the changing pixel resolution, you merging different data set with the with different resolution. Okay. People, for example, people coming from climate, they always use so maybe they never saw this. They always use with 0.5, 0.10, you know, degree. They never, or maybe rarely, they arrive to 1 kilometer. Okay, so they use more the shorter degree. Okay. Anyone was illuminating by this? And they say, now I get it, where all these numbers come from. Once I remember, I spent 1 day to try to do all this invert math to see where this number come from, to understand later on what I was doing. Yeah. Okay. So any resolution that you are thinking about, that you now, oh, which kind of data are you using? Anyone? Raster data with a particular. Yeah, Bonnie.
I'm using ERA 5 data.
Which one?
ERA 5 data, ERA 5.
ERA 5, ERA 5,
Yeah.
ERA 40, no? The European space, how you call it?
Yeah.
European climate medium weather forecasting, that one. So
Yeah.
that one usually are this kind, you know? 0.1, 0.5,
Yeah, 0.1 degrees. Yeah.
0.25. So usually this one, they're not very high resolution in terms of pixel, but they have a really high density in time, because you can get a lot of precipitation every hour, for example. Okay, yeah. So you have a really huge matrix, not in lat long, but in time. Okay, and we will see also how to manipulate. And people coming, yeah, using a lot of climate data, they come with NetCDF, the one that is abbreviated with .nc is the format. Okay. And in particular, I don't know, there is, if somebody wants to take note, there is the climate data operator, CDO, that is very powerful, is embedded in Bash, and is very powerful to work with this kind of raster climate data. CDO, climate data operator from the Planck Institute. Yes. Asma, yeah, Asma, please.
Yes. My question is, every satellite has a different range of resolution.
Sorry, with different range of resolution?
Yeah. like not range, like Landsat had 90, I guess 30 kilometer or
Perfect.
90
Yeah.
kilometer. But my question is, you are manipulating, you are changing the resolution. So we can change the resolution within that specific range. Like if Landsat had 30 kilometer or 30 meter, we will manipulate the resolution within that range, or we
Perfect.
can from that to 5 meter or 1.
Yeah, we
Usually
can change.
every satellite had different restriction.
Yes, we can change the resolution. We can change the resolution with GDAL Translate and with GDAL Warp, and we will see some example. Then, of course, you have to take into account, if you can, from a science perspective. Usually is always good to to maintain, or to the downsampling, for example, going from 0.5 degree to 1 kilometer is a bit, yeah, you can do it, but it's going to be a bit useless. So always, I mean, in the coding, you can do it, but then what you get is going to be a bit not scientifically support. So it's always there. You need a proper judge to do it analysis. Okay, good.
Okay.
Luca.
Yeah, for me, just another curiosity. So, for example, a resolution of 2.5 minutes. I mean, I know it is like the WorldClim dataset. I know it's around 20 kilometers at the equator, and I mean, when I had to work it, I just extracted the data, so I didn't really care about the resolution.
But WorldClim is not 1 kilometer. I think so.
I mean, yeah, the one I used was 2.5 minutes. No, just because I thought I understood this thing before, but now I'm a bit more confused.
2.
So let's say,
yeah, so it's going to be times 4. 2 minutes, you say, no? Because
yeah, let's say 2
minute,
minutes. Yeah, let's say 2.
yeah, 2 minutes is going to be like this. Yeah, so by 4. Okay.
And then I get the result.
Yeah. So this is, yeah, this is still degree.
That's still degree. Okay.
Should be that one, yeah. Because this one divided by 120 is half minute. Indeed, is the 30 second.
Okay.
Okay, good point. Yes.
Yeah, I always did it like from the other side, but this makes way more sense.
Yeah, whatever side. It's important that we get the same. Yeah.
Thanks.
Okay, good, Luca. Anyone else? Okay. So let's move into the so in the Jupyter Lab. So over here.
Could I just ask one question? So about the different formats, is there a particular advantage also computationally? Because sometimes I can choose whether to work with NetCDF, or I can choose to work with RIB, or I can choose what should I
very good question. So the default of GDAL and is the TIFF. Okay. And you can change format as much you want. Okay. So the NetCDF, for example, HDF, are very much used in the climate science, and also in some remote sensing. For example, MODIS and Landsat, they come in the HDF, and these one are called hierarchical data structure. Okay, also NetCDF hierarchical, because you can have different band or different sub-data set, they call it subset, sub-data set, and each subset, they can have different resolution, okay? Rather in the TIFF, you can have only one resolution for the multiband.
Okay.
So you can have multiband, but only one resolution. Rather, the NetCDF, you can have multiple resolution, and you can also specify, when you get the GDAL info of the NetCDF, you can specify even a description for each band, okay? So from that aspect, it's much easier to work with the format that you need. In terms of speed, probably is going to be the same, okay, between NetCDF and TIFF, okay? So I work more with remote sensing dataset rather than climate, So I use the climate and usually transform to TIFF because I have all my other file in TIFF. But if you want to maintain the TIFF, you can net CDF, you can. And once again, the CDO, the CDO climate data operator, if you know the basic of Bash, you will get in a few days. Okay. So it's a good way to work with this data.
Okay, thanks.
Yeah, good, Caterina. Okay. Perfect. So here I think I miss one command. Anyway. Yes, the open. No, it's over here. So there is one particular software. Let me open over here because in you can open. You can open also in. Let's see if it's working. It should work also for you guys. So if you run, yes, it's working. Okay, if you run this command, it's going to open OpenEV. Okay, this one was the software that I asked you. I mean, I asked during the installation to test and should work in all your machine. Is not a fancy software, a GIS software. It's very basic and it's very old, probably has 30 years and nobody's touching. And actually, I'm surprised that it's still working. But it's very useful when you have to open in a fast way all the different TIFF, okay? So over here, you have a bit of stretching of the, you can stretch the file and the file can change. Actually cannot really change. Why? Yeah, and in particular, maybe because it's you can, but sometimes you need to stretch one. Yeah. Okay, yeah, you can stretch the color with some algorithm over here. You can zoom in, zoom out, and something very good you can immediately see. You can see over here in this corner, you can see immediately the coordinates and also the value. So if you want to see something fast, you can see what does mean this one. Okay, so this one is also good. That is labeling, and we will spend a bit of time. The no data, so the typical big number is the no data, and this tell you that is no data is tell you also the value. Rather in QGIS or in other software, they tell you no data, but you don't know which number it is. And as you can see, I was opening all this file in a really fast way. So, and then you can zoom in, zoom out, a bit of this one. So it's very simple, but it's very fast for opening and understanding what is going on in the image. Rather QGIS, you have to wait, boom, 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 is opening, then change it, the right click and so on. So this one is for fast visualization. I use it quite a lot. Okay, and over here you need to specify inside you can then when you close it, is happening this one that you have to close. Over here you have to specify the full path, but in the yes, in the terminal you can just do it OpenEV. Okay, OpenEV, boom, OpenEV. Maybe didn't get probably the source. Okay, also here you need to specify. Probably I didn't put the source properly. Anyway, paste. Okay, so you open over here, you can specify. Look, for example, this file has something extra. I don't know which file I open it. Probably is not neither. And Landsat, yeah. So this file has something really weird over here. I don't know for any reason why. And you can immediately spot that something strange is going over there. You can see the big value over here that 0 is no data and so on. So it's very good for this fast rendering of the image. Okay, so try to use it. Okay.
Can you also use GDAL to open?
No, GDAL, yeah, GDAL is only for manipulation of the image. There's not a visualization. You cannot visualize the image, okay? So in the same way that you use OpenEV, you can use QGIS in the terminal, okay? And you can see that is, you know, is not so fast. Okay, look, it's still running, opening, and this one is good. This one, of course, QGIS is a more GIS software, you guys probably knows. And the OpenEV is also good when you work in a server. So if you are working in a server, you want to pop up the image in your computer, this one is the best way to do it if you work in the HPC. For people that will come to Austria, you will see how to work in the server with also with the OpenEV, able to show the image, okay? Okay, cool. What is the closing of this? Okay, this one, of course, if I open something in the terminal, I can also do it with Control-C. You can close it, and if it's not closing, you can do Control \, and this one is going to close immediately. So it's very good. You open it, you check what is going on, then you come back to the terminal and you do Control \, and you kill it. Okay, it's really kill it action. Okay, so let's spend a bit of time in this understanding the no data type. Okay, so this one is something very important that we need to really understand in order to mastering not only the TIFF, but the file and the file system of the computer in general. Okay, so I was very happy many years ago when they find this table and they say, okay, now I understood all where this number come from and why, and how I can use it in a proper way. So anyone knows already this table, or have been see this table a bit, but not in a real, people from computer science, maybe Kira. A bit, eh? Not so much. Luca. Yeah, okay, I think we need a bit. Yeah. So if you go over here, you get a really nice lecture from our colleague Lonzu that is going to explain the math behind, but I'm not going to go there, but because we need some more application. Okay, every time that you have a file that is not a text file, now we come back to the same knowledge, that is not a text file, is a binary file, okay? This binary file can be saved in different data type, okay? GDAL can support this data type. So when we do the GDAL info, I have it here, you can see that you have the data type that now I don't see over minimum, where it is. Let me see. Yeah, data type int 16 for sure is going to be also here by the, yeah, data type byte. Okay, what is this one? This is written in a text, but is nothing else the reference of this one, this table. So always print down this table. I have it here on my desk, and I always look because I don't know all this now. Okay, so the byte can go. The file that is defined as a byte can store value from 0 to 255. Okay, and these they come from the base bit. The 255 is nothing else, 2 to the power of 8. Rather, the unsigned 16 can go from minimum to maximum, from 0 to 65,000. Okay, and so on, all the orders. So they have a range where they can work. Over that range, they cannot work. So let's make an example. If I use it, for example, temperature in the Earth can go, let's say, from -50 to +50. I can use it. I have negative, plus and minus. So I need int this one, because I can go up to -50 and even more if there are, and +50 more than this. Okay. So if I want the temperature, also the decimal point of the temperature, what I can do, I cannot use it anymore, this one. I need to use the floating, okay? So if I want to save it 0.5, I cannot use this, and I need to use the floating. But pay attention about this. Look how big is this number. The negative and the positive is a huge, extreme huge number. And every time that you save 0.5, it's going to save up to 38 digits. Okay, so that numbers, the computer is going to treat if you do +1, okay? It's going to treat that numbers. So it's much better to do what? In this case, to multiply this one by 10 and save it as a int 16. And for people, for example, that was mentioned before, was using word claim is multiplied by 10. The temperature and the precipitation, no, but the temperature is multiplied by 10. Why? By 10 or by 100? In this way, they can use the int 16 that is much smaller. Look the size, how can be changed quite a lot, okay, between this one. So once again, the data type regulate the range, a maximum range, minimum maximum range of the numbers that you are going to do to save it in that file. If there is something bigger, it's going to be truncate and is going to be assigned or 0 if they are negative, or 65,535 if they are bigger, larger, okay? So this is very important to understand. Asma.
I know the integer and floating thing, but what is the C here? C int mean? What is the C float?
Yes, C is stay for the C language, but I'm not sure what does mean. Okay, so they have the same negative and maximum, and sometimes I think this one is we need to, anyone can reply to this question. I don't know. We need to check it. I think it's coming from the C coding, okay, that they can have a data type over there. Yeah. Okay, and check the floating 64. Okay, that are very huge number up to this. So in other words, try to avoid floating 32 and floating 64 because you are going to use a lot of size and computation for maybe you don't need it. Okay.
Then Gaspe, it would be great if we just save the file in the file drive where the file has a wide range. So it would be convenient we just use that file type that has the wide range.
Yeah, the wide range will be fine, this one, but look again the size. In other words, if I'm saving, for example, the typical land cover, they have 10, 20, 25 classes, typical. And so they are, all of them, they are in byte. Okay, so it's really depending what you have to save. If you have, for example, question for everybody, if I want to save digital elevation model of the Earth, which data type I can use it? In meter, not in feet. Anyone?
Int, maybe int 16.
Why?
Yeah, because like it resemble cover better like in meter cover of the elevation, even like in depth, even we got like a surface model we can use.
Yeah, because we have the Everest 8,000 meter, so it's including over here. And then we have the Dead Valley or Black Sea minus 400, whatever. Okay. So this one is going to save it over here fine. Okay. Can we Yeah, can we go, for example, if we want below the 1 meter, the centimeter, can we use this one?
Yeah, you just multiply and then save it.
Yes, but if you multiply 8,000 become 80,000, so 80,000 is not including this. You have to jump to this. Okay, so be careful. Okay. And then over here, no problem. You can say many digit after. Okay. Ishan.
Yeah, so does it mean that we have to like always save our files in a smaller image size, like using maybe the upper 4?
Perfect. If you can, yes, because you are going to save space and computation effort. Yeah.
And what if there's a really big file that we have to read in, and should we like do pre-process
No, if there is no solution, of course you can use the one that they, you know, the floating 32 and floating 64. You can use it both. Be careful, and there is also a very big explanation about this, but I'm not going to. Be careful when you use the 34. If you overpassing, the range can be higher, very high, but if you overpassing these two numbers, and especially to the, you know, negative and positive, you lose in precision. In other words, 2 plus 2 is not going to do 4. Okay, if you are very curious about this, check this lecture. Check this lecture, and is going to explain why. Okay.
Okay, thanks.
Okay, perfect. So now the data value. Pay attention. The data value is a number for the computer, and I show you in OpenEV. It's not like in QGIS or even in ArcGIS they say no data. No data is behind the labeling of no data. There is a number, and this number can be 0, can be any number. Is defined by the user, by you. Okay. Quite often, as no data, you use the typical minus 9999. That is fine. But quite often you are see this huge number, okay? Or sometimes even this one. How many times some of you have get as no data this huge number? Anyone? Come on, for sure, yes. Yeah.
Many times.
Perfect, many times. So, and this is where they come from. They are the extreme of the data type. Okay, so this is where they come from, this huge number that sometimes you see, and especially when you see .3438, and actually we saw in the OpenEV, are the extreme of this number. Okay, so pay attention that when you do the GDAL info, and also over here, no data value, look, this huge number, this is the extreme of this, okay? When you see no data value, doesn't mean that the pixel exists, that pixel in the image. Always pay attention about this. When you see GDAL info, no data value, minus doesn't mean that the image has 1 pixel or even more with that value. When you see the no data value, you have to remember, this one is just a label. If there is a value, a pixel with that number, then the GDAL will consider the TIFF, and also GDAL will consider as no data, as nothing. So when I do the statistic, and in particular the statistic, I do it with a -MM for getting the minimum and maximum, the no data value will be not showing. Okay, so if I do like this, I run this one, I get one value, and you can see that the minimum maximum is not including this, you know, because if not, it will be negative. So what does it mean? That is excluding this one. Now with the GDAL edit, I can fake the labeling, be careful, the labeling of the no data. And I can put -999. Now what I will have it? I will have it that my no data value labeling has been changed, and now my minimum is getting this huge number over here. So what does mean that I had some pixel with that value, very huge label. So always pay attention when you have a no data value. Doesn't mean that there is a pixel there. I mean, there in the image. It's just a labeling. And you can treat, and you have to understand very well this concept, because different software include in the statistic this number in according to the software. Okay? So it is always tricks. And when you change the no data value, the pixel value doesn't change. Okay? When you do this operation with the GDAL edit, this one, the pixel value doesn't change. You are just changing the metadata. Okay? So pay attention about this. When you treat it, no data, maybe come back and watch this lecture, and then you will say, ah, okay, now I get it, why this one is getting, and why if I do it like that one. Okay? Pay always attention. Yes, Kira.
So the original TIFF file just had null values and some pixels, and then GDAL info itself transformed those null values to this.
No,
this
it's
no
the
data
opposite. The pixel has always a value.
Okay.
Always there is a number in the pixel. The computer need a value in the pixel. Perfect.
Okay.
Okay. So then I have a labeling that tell me that that value can be no data or can be the data. Okay.
Okay.
It's just a label. And behind the no data, there is always a pixel. There is always a value. That's why we always, not always, quite often, to get the extreme of the data range. Because if I get the temperature of the Earth and I get 0 as a no data just in the middle, then I get the statistic, all the place where they have 0 in winter will be fake, because the statistic is not including the 0. So that's why always be careful that your no data value should be out of the range. That's why you put extreme of the temperature, for example, that we are doing. Okay.
Okay.
Always.
But in this case, why was there actually a pixel with an extreme value? Like when you changed to 9999, there was still a pixel with -3.8 times.
Yeah, because there are. Let's open this image. This way we
so
can.
There actually are.
In
this
yes,
case, there actually
yes,
were.
yes, right. I should have opened before copy. So this one in this particular case. Let's see. Let's clipboard. Yeah. So in this particular case, this one is. I think it didn't get the. Wait. Then I will tell you how to do it. So in this particular case, the no data value, I think I opened the wrong file. I mean, it's not there, this one second. Okay. Enable to, yeah, is it the wrong direct? 1 second. Because I'm not in the geo and see data exercise. Okay, that should be there. Yeah. Okay, so in this particular case, good that you point, over here is my C, in the C area, I have this huge number. You can see over here when I move the cursor here, then you have the C. As you can see, the black area, that is the C, is labeled as no data. When I've been changing over here the -99, okay, the value is still there, okay? So if I run it this one, and I reopen the file, we can see now, open, yes. So if I run this one, probably I didn't run before, but if I run it now, over here, I get my big number in the minimum maximum, and over here, I can open, okay, and I can see that my, okay, the label is still there. Maybe I'm not opening the right image. Vegetation. ATM 011. But if should be changed and no data. No data. Because I'm here. I'm okay. I get it. Anyone? Because I'm not in the. Because it's the slash media SF SE data. Okay. SE data. My SE data. Yeah. Yeah. Okay. Okay, sorry for the confusion. Now, over here, you can see that no data is not anymore over here. So I have been changing the label, but just the label, not the pixel value. Okay. We will see how to change the pixel value with GDAL and also with the PK tools. And over here, look, the pixel over here didn't change. You still have value, but what is happening that due to this number is very big, the color scale has been stretched, so it's not able to make a color like before. But the value over here didn't change. Indeed, if you, yeah, even if you stretch, you are not getting, but due to this, because you are stretching off the color between minimum and maximum. Okay.
Because
that makes sense.
Now the really high value looks like a real value that needs to be included in the stretch.
Perfect. Before they were masked as no data, and OpenEV was not coloring them, and our value, our color were concentrated between the minimum maximum that we had before, so between these two. Rather now, the color has been stretched to include also this huge number because we have pixel, so all the gray are concentrated in all the value of this area are concentrated in the color gray, okay? But this is also good because you can watching here, you can move in the cursor and understanding very well where they are, okay? And the pixel value and so on. Okay, so try to play a bit with this GDAL, with this no data to understand properly how they goes.
This also is referring to dealing with like outliers, censored outliers, like problem with acquisition, or also the no data. So like manage both of them.
Yeah, because quite often there can be outlier that they know. For example, the stripe in Landsat, they know that they come with a particular pixel value. So you can assign to this stripe that they always have the same number a no data value. And you will be able to get the statistic. When I say get the statistic, also getting operation, for example, when you do the sum between two bands, okay? So it's very important to understand this labeling because you can specify this stuff. There are some outliers that they are outlier, but they cannot be defined with a unique number. Again, cloud, okay?
Yeah.
So in that case, you can thresholding with a value, NDVR value, whatever.
Yeah.
You can thresholding and you can say, okay, above this number, change to -99 and sign as a no data. So all this possible is possible. Yeah.
So putting a threshold to like treating some pixel, some error, like error pixel, may I say, sensor as a no data, as a not true, like
Perfect.
true color with the clouds sample.
Yeah. Okay.
Is the GDAL info the only way to check what's the number for no data? Because I had this issue before, like processing a TIFF file, but then I didn't notice that the no data was there, so got a really weird result in the end. But then, this is a nice way to check. But is there other ways?
Yeah, with the PKInfo also you can check. Once again, the GDAL info, it will tell you if there is a labeling or not, and you can labeling, again, not changing the pixel value, you can labeling with the GDAL edit. The GDAL edit, be careful, because this one make an edit of the metadata, doesn't make an edit of the pixel value, okay? An edit of the metadata. So in this case, it's changing this one. So in your case, probably in the image, it was, for example, there was a typical no data -99 there, but then there was not labeling as a no data. And then when you did the sum, everything become negative because you have many 999. So always pay attention about this. And if it's not labeled, then you can label with this one. Okay, with the GDAL edit. Good question. Yeah.
Thanks.
So try to play during with this kind of no data, because you can understand more than these are the basic explanation, but then when you start to use it, then you will referring, okay, now I get it, why Giuseppe was mentioned this. But this is how you have to treat and so on. Okay, so let's stop it over here. We do a break and we come back at 20 minutes or so at 35. Come back at 35.
Sorry, Giuseppe, I think you might have the clock set a bit differently from ours.
Yeah, now I will stop recording.
Because,
no stop.
You've got your own time zone.
Yeah, because I mean, I guess we're all on like 53.
Okay. Thanks, Lucy. Okay, so let's go back to the to our lecture, and we can go deeply in the explanation of the use of GDAL. Okay, so why I mentioned the other time Bash is very important for the GDAL implementation for this, because I'm running, a for loop, a Bash for loop to calculate all the minimum maximum, okay, of my file. Okay, so if I run this one, it's going to list using all the file, go through all the file and get minimum maximum. So I can run this one. Okay, so as you can see, it's very fast. Okay, it's giving to me this huge number because is so if I want to get the maximum of the maximum, here I can start to play with my powerful AWK and say, for example, the maximum of the maximum, is this one. Okay, but I need to use it, the comma as a separator. So I can say -F, capital F, comma separator, and then say print $1. Okay, and say print, sorry, $2 because it is second. So if I run again, now I have only the maximum value. I don't have anymore the minimum. Okay. Print, sorry, $4. Okay. AWKF print $4. Okay, here I think there is a problem with the Jupyter notebook. Let me see. Print. Anyone can spot a mistake? $F.
I think it might be column 2, you were saying.
Right, bravo, yes, bravo, yeah. I counted it, yeah, with the space and yeah, okay. So over here.
Okay, sorry, can I just then ask a question? I mean, is column 2 because you said that the comma is the separator, so it's just creating 2 columns and then you get the second. Okay.
Yeah, bravo, Luca, yeah. So over here, and I can immediately spot that this is the biggest, and of course, if they are not sorted, okay, just as a coincidence are sorted, but if not, I can do sort -G, okay, and I can get the maximum of the maximum, for example, for each single image. And again, if you are working with a huge tile, so I'm working with the digital elevation model, you know, and I do some analysis, and I want to be sure that the analysis that I did, they are really keeping the maximum Earth value, so the average, the 8,000 meter. So I do the maximum of each single tile. If my maximum is 8,000, that means that is correct. So this kind of operation, as somebody else was mentioned, the outlier are always the extreme value. They are the best to capture this kind of value without, you know, open the image and checking. But so doing minimum maximum is the first requirement every time that you do it, an operation for raster data, even when you will see Antonio teaching the machine learning for the prediction. So again, you are doing the prediction of temperature, and then you do minimum maximum, and you see, you know, 200 degrees of temperature in the Earth, and then you say, okay, now there is something wrong with the prediction. Let me go back in the scripting procedure. Okay, so these are very, very common kind of, and here in how you manipulate the stuff. And this kind of analysis, I would say that is much better to do it over here in GDAL than not in Python with rasterio and so on, because loading the image, you know, then calculate is going to be much slower and so on. For these pre-processes, much better to do it in GDAL. Quite often I do Python programming for machine learning operation or other kind of operation. I take out my TIFF, and then in GDAL I do my minimum maximum to get outlier. Okay, so always try to get the best of each language. So far we have been not manipulate the image. We were just checking value, you know, with the minimum maximum. We were not manipulate. Of course, having raster file, you want to do operation between raster file, okay? And in this particular aspect, the GDAL calc is a Python code, okay? So when is .py is the GDAL calc. Yeah, and you can get a long help. And if you do --help, you can get a really huge help of these GDAL calc. And actually now look, I didn't see, they're really adding, you know, how you use GDAL calc with example, okay? So for example, if you want to do the average between two files, okay, you can do like this, and you can do A is the first file, B is the second file, and then you do A plus B. Okay, so over here, you have NumPy operation. Okay, so whatever you do as a NumPy syntax, okay, you can do over here. So for example, this one is a typical logical operator in NumPy. So if you want to do something specific as a mathematical operation, you have to check the NumPy, Python NumPy syntax in order to be able to write inside over here. Okay, and this is the fancy way you can change all the value. Now I don't remember this one, I need to go and check, but all the value bigger than 100 for A and smaller than 150 do some kind of operation, all the rest become no data, something like this should be, okay? Look, for example, set the value of 0 and below to null. So this one is very common also to use transformation, okay? So this is NumPy. Yes, it's a Python programming, so is slightly not so fast than like GDAL translate and GDAL warp. So be patient if something is not coming really fast. Of course, when you do this, be sure, so when you are combining different files, especially this one, be sure that all your files have the same pixel file, the same pixel size and extent. Because if not, you don't know what it's doing. If there is different pixel resolution, I don't know neither if it's going to complain or not, or what it's doing in the extent where you don't have the other layers. So try always to be aware that these tools, more your file are constrained and well organized in terms of extend the pixel resolution, better they work. Okay, because sometimes you get a result, but you don't know what it is. If it is done an internal resampling or if it's making an average between the pixels. So it's really, you don't know. So if you can do it before, then you know that if the sum is going to be the sum of these two pixels, no problem, if the matrix are very similar. Okay, so over here you can you can see all the options. Be careful that over here there are always two dash, okay? And also look, this one is, you need also to interpret this one. Look this one, output, no data value. So this one for the output. So this one is going to labeling the output no data, okay? Rather this, and actually this one is new, is going to consider hide the no data, so not consider the no data inside to the calculation, okay? So be careful about this one, is quite new. 1 year ago it was not there. So be sure about how you're reading carefully all the manual, especially with no data, because you can, and that's why it's good to have a very huge extreme value, because then you have, if you have the nice 99 and you do the average, everything will become negative and you spot immediately that there is. So always get a no data value that is to the extreme value. Luca.
Yeah, very quick question. So does this mean that it does not ignore no data values by default if there is this option? Or
I think yes.
So you need to specify to not include no data in the calculation.
Yeah, no data value, ignore the no data value, but I'm not sure if you need to specify the value also. No, because this one, yeah, I think it just, let me see, ignore no data. Yeah, a value. So you can put a value over here. Can you put more than one? I don't know. Something that you need to try. Okay, because if not, you should be comma, another value. Sorry, over here. No, sorry, I click this one. So this one, for example, is going to ignore the no data. So once again, if the no data has been labeled as, you cannot specify here the value. So what does mean that your T value need to be labeled correctly before to do GDAL with this operation. Okay, so always be sure that what you are doing. Over here, there are some creation options that are very important for the compression of the file. So if you go back over here, you can see that -co, you can compress the file. Always compress the file in GDAL Calc, in all the GDAL and PK tools. So there is always the same. I always use, there are different kinds of compression algorithm, but I always use compress deflate. Zeta level is the level of compression, because the file, they can become, without compression, they can become 10 times bigger. So it's not just 10%, 10 times bigger. So it's very good to always compress your file, because it's very easy to fill it up. Also, during the compression, the speed is not really going down, okay? So don't worry, compress it and saving time, okay? Also be careful about this one, in order, if you are doing the vegetation index for, vegetation index, so the typical NDVI expression, so let me make bigger this one, the typical NDVI expression, you have to be sure that not only the output is floating, because your value goes from -1 to +1, and all the integer, decimal in the middle, but also the internal computation, during the computation is done in floating. Okay, so this one again is an NumPy syntax, to be sure, and if you guys Python master, you should immediately understand that this one is coming from NumPy, okay? So be sure also to specify how the internal computation, not only the output, but how the internal computation need to be treated, okay? And of course, if you want to do, during the running, you can get all the process. These are nothing else, percentage of the process. As you can see, it's quite, okay, they are not huge files, so they are quite fast. And here you can get the, that all your value are becoming this one. Look, the no data value, is the extreme value of my floating point, okay? So I didn't specify here, actually there was not this one. So let's take this one, no data value, and put it, because this is quite new, this one, and put it here, no data value, and we can even put -2, because we know the negative, they go -1 + 1, and now you run it. Now if you do run of this one, you should get that your no data value now is -2. Okay, so this is how you, so as a default is giving you the extreme of the floating. And so this is a good way to understanding, okay, if I don't put anything, what is going to label? Once again, is my -2 over there? I don't know. Okay, I don't know if it's over there in the image. We can, probably not. Yeah, probably not, because this one was 0 even before. Okay. Okay, anyone was already using GDAL Calc? No? Okay, so this is a good way to use it, because most of the operation between bands, you can do it with digital calc. You can get also something very good. They also adding, okay, this one a bit 3-4 years ago. You can specify the band, so you can have one file. If you don't say anything, it's going to be band number 1. But then if you want to, a specific band of the file, you can do this. Okay. So where is it's not Isam. So also Isam was asking me, can you do a composite of the image using the quality control, one band that does the quality control? Okay. With this one, I would say yes, but you have to do some pre-analysis. So first you have to apply the quality control to one band and give them -99, for example, and then use the hidden no data to specify. So also this one is going to be good for that reason, but we can see that PK composite goes much deeper in this kind of operation. So, but with GDAL calc, you can start to do it, okay? Okay. Good. So we saw band manipulation. Now we see how we can, we can change the pixel resolution. Kumar was the question, Kumar.
Yeah, I'm wondering, sometimes I'm just like normalize the raster maps. So between 0 and 1. Also, I have no data, but I'm not sure how should I deal with this no data. I have 0, which is real 0, but also no data. And when, I mean, in a case when we want to just overlay different layers together. So what is the best strategy here?
Yeah, here we are close. Okay, if I understood correctly, we are so if we have one value, as you mentioned, 0, that can be a real 0 or also no data. If this is the case and you don't know, you don't have an additional band that tell you which one of the 0 is good, let's say, then you can select. Okay, you can select in advance. But if okay, then we need to check the data per se, but quite often, for example, going back to the example of Laura before, that is something, I would say something similar. I would try to check where are concentrated my good and bad 0, okay? And if there are additional band or layers, polygon that allow me to this kind of interception. But again, it's really file oriented, so we need to see how they are, okay? In terms for scaling, I think you also mentioned how I'm going to scaling my number. So in GDAL translate, you have I think you were referring to this, GDAL translate, you have the minimum maximum scaling. Yeah, scale one single band, and you can from 1 to 2 become from 2 to 20. This is how you're scaling. And of course, when you're scaling, what is happening to the no data? As a default, GDAL will not treat the no data. But again, something again to be sure, okay? And how you can be sure? Even with the histogram that I showed before, that we can see in PK stat, if your number of no data doesn't change as a number of pixels, that means like he didn't do anything. Rather, if it become more or less, means that something has been added. So over there is where you have to play with these tools and try to do it properly. Okay. But anyways, also you guys try to work for next week for this kind of example, and then we can see one by one. Okay, so these are good example how to for learning the different options that we have, because of course I'm not listing all, there are so many.
Last question here, since we're in the scale. Can you assign one band with 2 numbers into one by GDAL? Like there are several bands in my data, and I want to only use one number, one single number presenting each band. Is that Haskell in GDAL.
One single number? Sorry, can you?
Yeah, for example, one band is from 0 to 30, and I only want to show 30 for this band. And one from 30 to 100, and I only want to show 100.
Yeah, I would say this one is the GDAL calc.
Yeah.
With the logical operator that we saw before.
Okay. Yeah.
Okay, so over here, if we go back, over here, you know, in this one, this logical operator allow you to use some particular thresholding. For example, here between A is file number A, number 1. Okay, and this particular is band 1 of this file, and this one can be band 2 of this file, you know. And here I'm just using, actually here is doing 2 multiplication. Look, I never noticed this one. So this is, we need to see how they're doing one with the band with one input file, and this one with the only one. So probably the output is 2 band over here. So this is the way how you operate with the logical operator. And probably that one is possible to do it. Yeah.
Yeah.
I never saw this one. Yeah. It's a good example.
Yeah.
Okay. Very good. So we talk about GDAL warp for changing pixel resolution, you know, and you can do a for loop for many files to change the resolution. And in this particular case, you can see that, you know, the resolution is this one. Okay, so you are going to change the resolution, and this is how you set the resolution. So before the resolution was, yeah, you're becoming bigger, probably. Maybe it's not this one, the file. So we should open and check the resolution of these. Let's check it. GDAL info. Okay. This way is printing. So now it's printing, and look, is running. So it's printing, my mistake. 1 or 0 1. Oh, 1 should be. Yeah, so it's printing the GDAL info. So now the GDAL info was 08333. Actually, I don't know why, but maybe it was coming from the, I didn't change the resolution. Over here, I could going down in the resolution, you know. And actually, this one is also wrong. I should put 3333 over here. Okay, always be sure that your pixels are also equal in the X and Y dimension. So repeat over here, you know. And this one is going to give me the extent. Okay, so always try to avoid this kind of rounding. Always put, you know, full degree. I always try to work with the full degree, even if my extent is bigger, or 1 digit. Okay, 1, 2, just after the comma. Don't put, you know, this kind of cropping, because if not, it's becoming a very difficult to understand what is happening in the end, you know, of the extent. Rather this one, we know that this one is 100 divided by 180, 20, sorry. So you know that you can do the math to see how many pixels you have in the image. So try always to work with this value. You can see over here that you can compress always with the same. It's slightly different, the syntax, but I'm using the same. Okay. Somebody was.
Yeah, sorry, it was me.
Something.
I can't see how to put my hand up. I'm trying to watch you on an iPad and work on the laptop.
Okay.
So I had a question about this command, because you're not specifying a mode of resampling. So what's the default that it will use?
Yeah, good question. Over here, yeah, actually over here I didn't
put it in the documentation for GDAL warp. So
perfect. So in the GDAL warp, Lucy mentioned, what about the resampling technique? And you can see we can talk about resampling for you have as a default is the nearest neighbor because it's the fastest, okay, but it's not always the best, okay? It's really depending what you have to do it. So there are few rules that you have to keep in mind, and then there is a bit of fluctuation.
So that interpretation of nearest neighbor will be the center pixel of the kernel.
Yeah, perfect. Yeah. So in so nearest neighbor, you use it when you in two cases. When you have categorical value, so you want to go from land cover resampling or warping resampling or warping, or when you change the pixel value and there's slightly very similar, 20 and 22, or 25 and 30, when they are very similar. All the other cases you can use among these one. And again, it's a matter of what you are searching for. Okay, so if I have to resampling a digital elevation model and I'm interested in the peaks of the mountain, I'm going to retain the maximum value in my matrix that I want to resampling. Okay, so rather if I'm going to check for river network, so I'm going to resampling, getting the minimum, and so on. So it's really depending what you have to do it. This one, the bilinear, this one, they create a smoothing surface, and in particular, cubic and cubic spline is more smoothened than bilinear. So usually with bilinear, you obtain a good resampling without too much interpolate between the other pixels. Rather, this one, cubic and cubic spline, they really smooth a lot the surface, okay? So I don't want to say never use it, but be careful about what to use it, okay? Yeah, so for the same, something really important, and we will see this one, really in particular, the GDAL location info, okay? So you can getting the value in one specific coordinates by using GDAL location info. Saverio, this is for you. And for everybody that are going to retrieve point location, information at point location from a raster. So if you get GDAL info and you give the name of the file, plus be careful about this one, they can be the coordinate or they can be the row and pixel of the image, okay? So if you don't specify anything, are the row and column. Actually, I think it's first column and then row. So X and Y, okay? So you can loop it, and I'm going to loop, at this point over here. So these are very good to understanding what is happening, for example, close to the border of an image. So over here, I'm looping through, let me see, data location info. So you have X and Y. So if it's X and Y, I have, I'm moving 1000 through the columns X and then 0Y. Okay, 0Y should be the top. Okay, so in other words, I'm checking all the column, all the first row of the image, what is going on. Okay, so always, is it clear? Actually, no, you're right, sorry. The first column, the X is this one. So I'm checking, yeah, it was correct before. Yeah, I'm checking the 1000 column in my matrix at 0, yes, at 0 level. So just 1 pixel in the top, okay? So of course, if I want to loop through all my line, I can looping and increase this 1, 2, 3, 4, 5, 6, 7, having the X fixed and the Y changing, and I can get the value of one line, okay? So these are very useful for this kind of checking the image value in one specific pixel, or if I put a coordinate over here, geolocation, and I give my lat long, I can get the value. So I'm looping at this coordinate. Quite often I use this and the coordinate. This one, the previous one. Yeah, you can use it sometime, but it's not very common. But for example, for the people that does species distribution, or like Saverio is doing landslide modeling, because he has sampling at one point location. Many people have point location sampling of soil or other kind of analysis. Then you can do this kind of looping. Okay. Now yeah, I think we are over the class because I start late. I get smashed with the time. Anyway, I will finish this. And of course, you can also looping. You can looping in one specific file. So for example, over here, I'm creating just one little file, okay, with a lat long. That is going to be my geodata X and Y txt. So now if I loop through all my image and I'm feeding my text file, and that's in this case, this one is going to be your text file, and Anita also for you, of all your landslide is going to give you all the information about that specific point. Okay. Okay. So I would say everybody can, as an assignment, everybody can get a little, create a text file or X and Y coordinate, even if you don't, just fake some coordinates, whatever, and start to play, with this, because it's going to be extremely useful for creating the table for the machine learning. Okay, this is how you do it, the table extraction. And in particular, there are, due to that we are here, last year we did, I will send it to you. We did a little competition about who is getting the fast way to extract file, and there are 2 or 3, 4 solutions, even with Rasterio, for example, and this one was the fastest. So I really emphasize this way of extracting point at this lat long location. Chiara?
Sorry, just a very quick question. Since I work with net CDF files, is it possible to do the same to that?
Yes, because whatever you read, I'm using the TIFF, but GDAL is going to read everything.
But it's a stack of images over time that I have as a net CDF file, because I have just one net CDF.
It's going to, you can try. I never did it, but for sure it's going to do it. We can see it's going to be challenging to select the sub-data set, so you have to play a bit, but it's possible, and probably is going to give you, all the band one below the other. But there are ways to shift the band in the right position later on. Then this one is a text file, and then you can manipulate with awk or whatever you like. Okay.
Okay, thanks.
Okay, cool. So I will send it this as an explanation, this competition, and you will start to play with this. Okay. Okay. Done for today. A bit